Hello guys, now we're going to solve some exercises here. Find the center and mass of the lamina of uniform density hole, right? I'm just going to call it P, bounded by the graph of f of x equals 4 minus x squared in the x-axis. Okay, so if you have a graph like this, okay, the x and y-axis here, so this is going to be the x, this is going to be the y-axis. This lamina is something like that, okay? Of course, it's not perfect. It's supposed to be like this. It's a parabola, okay? Kind of like that. This is going to be 2 because f of x equals 4 minus x squared. So you know when x is 0, the thing is going to be 4. So this is 4, okay? And when x equals 2 or minus 2, 2 squared is going to be 4, 4 minus 4 is 0. So this is 2 and this is minus 2, right? So you know what I mean, minus 2, 0, 2, 0. This point right here is the point 0, 4. Okay, so it wants to find the center of mass, of this lamina. Well, because it's symmetrical, of course I didn't draw it symmetrically here because I'm not a robot, but this side is exactly the same as this side. So the x bar is just going to be 0. Okay, the center of mass is going to be some point in here. Okay. Hold on. Oh, that's weird. Okay. Now we gotta find y bar. Well, y bar, okay, the center of mass with respect to the y coordinate is gonna be the moment. I always make the moment about the x-axis divided by the total mass. Well, the moment about the x-axis is gonna be equal to it's the power rotation of this lamina, okay, around the x-axis for each one of the points, right? And we're going to be integrating with respect to x, so we're going to have vertical bars like this, okay? This one, then this one, then this one. Let's just think about this one here for a second. So what is going to be the because you got to divide by, well, okay. What's going to be the mass of all these bars, okay? Well, it'll be whole, okay? I'm just going to write it as a P here, which is the laminar density, or which is the mass divided by the area instead of being by the volume, times the integral of f of x minus g of x. Well, g of x is just 0, okay? So you don't have to worry about that. So it'll be f of x minus g of x, which is going to be this thing here, okay, times dx. So this f of x minus 0 times this dx in here is going to give you the area. The integral of this, okay, will give you the total area times the density will give you the mass. Okay, now with this I have the mass. But I need the distance from this mass of this thing here to around the x-axis, and that'll just be f of x plus g of x divided by 2. So you're going to multiply this by f of x plus g of x, which is 0, divided by 2. So it's just this stuff squared divided by 2. But the divided by 2, I'm going to put it here. All right? Now, what is the f squared of x? Well, it's going to be 16 minus 8x squared plus x to the 4th. So I'm going to drag this here. Yeah, I'm gonna drag it there. This one here, and I'm integrating from minus 2 to 2. Okay, so it'll be p divided by 2 times 16x minus 8x cubed divided by 3 plus x to the 5th divided by 5 minus 2 to 2. So this 2, I'm just gonna leave it outside now. The whole thing is gonna be 15. Okay, so I'm gonna go like p divided by 2, and in here minus 2 and 2, or maybe I don't have to do that. Yeah, I don't have to do it. So let's plug in the do here. Let's plug in the 2. That's going to be 32. Here you have 8 minus times the minus 8 minus 64 divided by 3. Yeah. Plus 32 divided by 5. Right? And now we have a minus. Okay, minus 2 times 16 minus 32, with that minus plus 32. Now, this is going to be minus 8 times minus 8. Yeah. Okay, so minus 8 times minus 8, 64 divided by 3. But because there's a minus, minus 64 divided by 3. And then you have, this is a minus 32 over 5. But because there's a yeah, it'll be minus 32 over 5. With this plus, there's a minus. But because of another minus, it'll be plus 32 over 5. Now, see, you have 32 plus 32. It'll be 2 times 32. 2 times minus 64 over 3. And plus 2 times 32 over 5. What I'm going to do is just, because I can simplify, I'm going to get this 2 out of here. I'm just going to erase all these duplicates. All right? I'll bring this over. So this now is going to be p times 15. It'll be 15 times, well, it'll be 320 plus 160, that's 480. 5 over 6, well, 0, go 5, 0, 2, 30, 30, 32, okay, plus 3 times that, well, it'll be 90 plus 96. All right, so it'll be 160 here plus 96. 260 minus 4, 256 divided by 15. It'll be p equals p 256 divided by 15. All right. For that's all for now. That's mx, okay? Just wanna think here. And now we have to calculate the total mass, all right? So this is mx. So mx, I can just, hold on, I can do that. Mx equals this. And now we have to calculate m. I'm gonna erase this stuff, okay? Oh, m is the integral, okay? You have the thing here. You have this stuff. I'm just thinking about something. Okay. So you have this, the integral from minus 2 to 2 times, it'll be f of x dx. That's all. Because f of x dx is going to give you the area times the density divided by the area. You're going to get the mass. So it'll be f of x dx. And f of x dx is this, right? 4 minus x squared dx. So let's do that. This is going to be equal to p times minus 2 to 2, 4x minus x cubed divided by 3. So substituting is going to be 8. Okay, 8 minus 8 thirds. Okay, and then you have minus 8 here plus the minus 8 plus 8. And here you're going to have minus 8 thirds with this minus plus 8 thirds, but because there's a minus, it'll be minus 8 thirds. Minus 8 thirds. All right, this is going to be the mass. So you know, it's going to be like, you got a p here, and then you have this thing, that'll be 3. Now, I'm just going to consider, you see, you got an 8 and an 8, minus 8 thirds, minus 8 thirds. So these 8s in here, I'm going to consider them 16 and just discard this stuff. So 3, this is going to be 16, right? 3 times 16, 48. And here, you're going to have a minus 16, which is 32, p, 32 over 3. All right, this is going to be the mass. Okay, so the mass equals that. So we can do that in here. It'll be P 256 over 15. Okay, divided by this. Well, we're going to divide, so we multiply by the reciprocal. I'm just going to separate this. Oh man, I'm running out of space. I'm going to put it down here. I'm running out of room. It'll be times 3 divided by P 32. See that when you're trying to calculate the centroid, you don't have to worry about the density. You can cancel these densities here out. And then this 3 here, I'm going to get it out, and this becomes a 5. All right, so it'll be 256 divided by 160, right? In simplifying that, well, if you, let me just think about one thing. You can divide everything by 8 and get 32 over 20. Divided again, it'll be 16 over 10. Divided again, it can be 8 over 5. So yeah, so 8 over 5 is going to be the center of mass y coordinate. Okay, so 8 divided by 5 is not even 2. So if we consider this 1 going to be slightly larger than 1, it'll be kind of in here. Okay, and now I'm going to show you. That means that if you have a metal plane, a metal plate with this shape, exactly with this shape, with homogeneous density everywhere, and you put a pencil in here, you're going to be able to balance it. Okay, it's not going to fall anywhere. And I'm going to show you the image. See that? Center of mass 0, 8 divided by 5. So 8 divided by 5 is a little bit larger than 1. Okay, and so you put a pencil here, you're going to be able to balance it. It's not going to bank, it's not going to fall this way, right? It's not going to fall this way, and it'll be perfect. It's not going to fall this way, and it's not going to fall this way. It'll be perfectly balanced. Okay, so let's go to the next exercise. Hey, so now we're going to solve yet another exercise here, we're gonna do the same thing, find the centroid or the x and y coordinate for the center of mass of this region right here. Okay, so let's do it. We gotta calculate many things like f of x minus g of x. Well, f of x minus g of x, okay, it'll be 4 minus x squared minus x minus 2. So it's minus x squared minus x plus 2. Now you also have to calculate f of x plus g of x divided by 2. So this is going to be minus x squared plus x plus 6 divided by 2. Okay. Now, we're going to have to, for example, to get the m about the x, right? The moment about the x-axis was going to be these two multiplied, all right, dx. So let's try to do these two multiplied in here. You're going to have x to the 4th divided by 2. To get an x cubed, it'll be minus half plus half. So it's going to be 0. Right. That's right. See, it'll be minus 1 plus half. So it's going to be minus half x cubed. And there are other ways doing this. X times x squared. So it's going to be plus x cubed divided by 2 plus x cubed divided by 2. So it's just 0. Okay. In order to get an x squared, so let's do this. It'll be minus 3 x squared. Right. Another way to get an x squared is multiplying this one by this. So you're going to get minus x squared divided by 2. And another way is multiplying this by this. So 2 minus half, it'll be minus x squared. Minus x squared. To get an x, we have to multiply this way and this way. Okay, so in here it'll be plus 3, minus 3x, minus 3x. And with this one, it'll be plus x, right? And this is going to be 3 times 2, 6. So plus 6. All right. Now, minus yeah, this, I'm just going to cancel these two. All right, this one over here, it'll be minus 3 minus half, minus 3 halves, minus 1 minus 4 halves. So minus 9 divided by 2 x squared. Just want to see one thing here. Half times 1 minus half, minus 1 times minus half plus half. Yeah. So this is already taken care of. And over here I have minus 2x plus 6. All right. Now you see I'm gonna exchange this. I'm gonna put a 2 here. That means minus 4x plus 12. Okay. Because now they all have a denominator 2, right? This is this times this stuff. And m of x, m about the x is going to be this thing times dx, which is going to give you the area. All right. There's something else. You see the density here is 1, is to be considered 1. Okay. All right. So it'll be this thing, the area. See, this is gonna be equal to mass divided by the area. Okay, anyway, I'll take care of this later. The moment of x is just going to be this stuff times dx, which will give me the area, times this stuff, which will give me this point right here. Okay, so we have to integrate this. Okay, it'll be the integral from -2 to 1 of this thing dx. So I'm just gonna put I'm gonna get the half out, and let's do this now. From -2 to 1, it'll be x to the 5th divided by 5. It'll be minus 9x cubed divided by 3 minus 3x cubed. Yeah, 9 divided by 3, okay. Here you have a minus 2x squared, right? Plus 12x. All right. So I have to take the minimum common denominator. It'll be half times this minus 2 to 1, or maybe not. Maybe not. I'm not going to take the minimum common denominator now. Let's just do it. So it'll be 1/5, okay, minus 3 minus 2 plus 12 minus 32 divided by 5, but it'll be plus 32 divided by 5. And here you're going to have a negative here, negative, and another negative will be negative. So 8 times 3, 24. Negative, it will be positive with this negative. Positive here with this negative, negative with another negative, positive. So it will be 4 times 2, 8. And this one in here will be negative with another negative, positive, 24. Okay, so this 24, and I'm just gonna put this in here. So this 24 with that 24 is gone. Okay, and now let's just say that it's half times, so it'll be, the whole thing is going to be 5, right? But here's the stuff, I'm going to add all these things. So it'll be minus 5 plus 12, 7, 15. I'm just going to erase minus 5, yeah. I'm just going to do this. It'll be plus 15, okay. It'll be 1 plus 32 plus 75, okay. I'm gonna do, over here is gonna be 10, 33, 108, right? Okay, so dividing by 2, you have 54 over 5. Okay, yeah, 54 over 5. This is mx. Okay, so let me try to get myself organized in here. I'm gonna say that mx is equal to 54. This 5 is just not work. 54 over 5. Now we have to calculate my. Now my is going to be equal to the integral from -2 to 1 of fx, right? F of x minus g of x dx. So it'll be minus x cubed minus x times minus x squared. Hold on. Minus x cubed minus x squared plus 2x plus 2x dx. Let's do that. It'll be integrating that from minus 2 to 1, minus x to the fourth divided by 4 minus x cubed divided by 3 plus x squared, which equals it'll be minus 1/4 minus 1/3 plus 1, right? Now 16 divided by 4, 4, so going to be plus 4, going to be a plus, minus 8/3, and this is going to be plus 4 minus 4. Okay, so forget this and forget this, right? And now I'm just going to say that this is a 3 over 3. So this whole thing, put in a 3 here. Minus 2 plus 3, 1, minus 8, minus 7/3. Yeah, which makes sense. Minus 7/3. Okay. Minus 2 plus 3, 1, minus 7/3, yeah. Oh, no, there's a 4 here. Hold on. I'm going crazy. Let me undo this. Okay. There's a 4 here. I forgot about that 4. So this is going to be equal to, I put 12 minus 3 minus 4 plus 12 minus 32, right? Yeah. Okay. So this is going to be 12 minus 7 plus 5, 5 minus 27. Okay. Now divided by 3, you can do a minus 9 over 4. Yeah, I think it's right now, minus 9 over 4. It'll be minus 9 over 4. Okay. Now we have to calculate the m. The m will be the integral of this. M equals the integral of this from minus 2 to 1 dx, which is minus x cubed divided by 3 minus x squared divided by 2 plus 2x. And now we do the minimum common denominator, or maybe not yet. So minus 1/3 minus 1/2 plus 2, and then you have minus 8/3 In here, 4 divided by 2. Okay. 4 divided by 2, okay. And here you have a -4, but it'll be +4. Okay. So I think I'll check the minimum common denominator this time, a big one, which will be 6. So it'll be -2, -3, and then we have +12. We have a -16, and here you have a +12, and here you have a +24. Okay, this equals -7 -16 -9 +12, 3, 27/6. Okay, let's try this again. There'll be 7 here, right? -9, 12 -9, 3, 3 + 24, 27 over, okay. And you can divide everything by 3, so it'll be 9/2. Yeah. So the mass is 9/2. Now let's do it. The x bar equals m about y divided by m. M about y minus 9/4 divided by 9/2. Minus 9/4 divided by 9/2, so it's times 2/9, which equals -1/2. Yeah. The y bar is going to be the moment about the x-axis divided by m. So this is going to be 2/9. And here the mx, right? Yeah, mx, hold on, 54/5, I guess. (54/5). Right, now this is gonna be 6, 12/5. That's it. These are the coordinates of the centroid. Complicated stuff. Too much arithmetic. All right, guys, that's it.